Hello, I'm Anna Mackay and this video is on the equation of a circle in expanded form. It's also the last in our series. So the expanded form of the equation of a circle is x squared plus y squared plus ax plus by plus c equals 0. Now our previous video was on the general equation of a circle in center radius form. So we've got two examples to work on here. We're asked to find in expanded form the equation of a circle and we are given the center and its radius. So you actually start off using the center radius form and we have to expand that. So hopefully you remember what it is. It's formed from the distance formula. So we have x, subtract, then you look at the x coordinate of the center, so subtract 4 all squared. Now in this equation there's a plus that comes there now. Bracket y, subtract the y coordinate of the center, because that's a -1, it turns into a +1 there, all squared, is equal to the radius, which is 2 all squared. But the question asked us to find in expanded form. So we take that equation and expand the brackets. So this is where your algebra skills need to be good in terms of expanding a perfect square. Don't put an equal sign here at the beginning. If you're tempted to, put a therefore sign instead. We only ever have one equals per line. So expanding that out, we have x squared. Bit of a refresher in case you need it. I think of this first term multiplied by the second term. So we'd have -4x and it's twice that. So -4x times by 2 gives us -8x. Then you look at the second term, the -4 squared. That gives us +16. So it's always a positive in that position for a perfect square. For the rest of the formula, we have an add, which is always handy because then we don't have an extra negative to deal with there. Expanding out the y bracket, y squared. Then you look at that term and the one term, multiply them together to get y. Times that by 2, we have 2y plus this one term squared, so +1. And that's where we turn that 2 squared into 4. You could leave it there, but it's not in the form. The expanded form has descending powers, so we would write our x squared term and then our y squared term. Then we have the x term followed by the y term. So subtract 8x plus 2y, and then the c, all the constants grouped together. So you've got 3 to take into account. You've got the +16, the add 1, and this 4 has to come over to the other side and be subtract 4. And you group all of them together to get +13, and therefore the right-hand side is equal to 0. So that is our expanded form. Now, what if you had something like this and you had to put it in the center radius form? We have to complete the square. So work with me on this one. So first of all, we have to look at the x terms and the y terms, and we have to complete the square on those. So let's set it up so that the x's are together. So we're going to write out the x squared and then bring the other x term next to it, plus 8x. Now, leave some space for the constant value that's going to go with the x bracket. So I'm leaving some space and then I'm putting the y squared term and the y term. So subtract 6y, again, leave some space. Now put your equals, and this 11, -11, take to the right-hand side to make +11. Now, a refresher on completing the square. We have to look at the coefficient of the x term, and you have to divide that by 2 and square it. So I'm just going to do some working out off to the side here. We take the 8, divide by 2 and square it. Pardon me. You might be tempted to make that, so that would be 4 squared, so make that 16, but don't. Don't work it out. Leave it as the 4, so 4 squared. I'll come back to that in a minute. The second one, the y term. So you take the coefficient of that y term, divide it by 2 and square it. Do not write 9. Think about what it's -6 divided by 2. That gives us -3 in brackets all squared. Now let's go writing these back up here in our formula. So we look over at our x term squared, so we get 4. So we're going to write this plus 4 squared here. Now, the rules are what you do to one side, you must do to the other. So if we are adding 4 squared to the left-hand side, we must add it to the right-hand side as well. So over here, we're adding on that 4 squared, which will help us to complete the x portion. The y portion, we need to add on -3. Please don't put a subtract there where we did the add. That's all part of the formula. So put the -3, whenever you get a negative, keep it in the brackets. Now to the right hand side, you must add that on as well. We're adding on -3 all squared. Now we can tidy that up. So we're going to look at our x terms here, and we've completed the square, so we're going to factorize that. That's a perfect square now. So to write a perfect square, we have our brackets. We'll have x here at the beginning. It'll be all squared, and you look at the constant term, and it's +4, so we'll put +4 there. And if you wanted to check that, remember a perfect square, you would multiply the x and the 4 together to get 4x, multiply that by 2, you would get your 8x, so check, we've done the right thing. The next part, we add on, and we need to factorize the y term as a perfect square. So we look at the y squared term and we put a y there. This whole thing will be squared. And now the number that we put in the second position is -3. So you can see why it's really handy not to have written that as 9, because that -3 is the number that we put in the factorized version, so we don't have to rethink it going from the 9 back to a -3. You can always double check. Y multiplied by 3 gives you -3y, times that by 2 gives you the -6y, which is what we had. And on the right hand side, you work out all of those numbers. Feel free to use your calculator if you need to, and I can tell you it comes out to be 36. But go back and read the question. That's what my maths teacher always taught me to do. It didn't say leave it there. It said find the center and the radius. So you actually need to state what they are. So the center is the x coordinate. You look at this term and you keep the sign, so it's positive, and the y coordinate will be -3 for the center, and the radius is that number, 36, the square root of that number. So if it's a number like 30, you would feel free to write the square root of 30. But if it is a squared number, square root that and write the simplified version. I think that's what I'm trying to say. So we write 6, and we tend to write units as our unit of measurement. It's not centimeters or anything like that. It's 6 units for the radius. So quick crash course in completing the square and center radius form. And that's the end of this series. Subscribe to the channel and a thumbs up, and we'll see you next time. Bye.